Hello everyone. So today we are going to be doing Unit 8, Lesson 3 notes. We're going to be talking about the surface area and volume of cylinders and cones. Okay, so um, today's stuff is like a lot of review. All the formulas, everything we're going to be learning today is what we've learned already in previous classes, but now we're just going to be combining them. So first thing we're going to talk about is the cylinder. So a cylinder is very similar to a prism, but with two circular bases. So we got a circular base up top, circular base on bottom. The altitude of a right cylinder is the segments joining the center of the circular bases. It's going to be your height here. And then the radius of a cylinder is the radius of the base. So we got the radius here, it's the radius of the base. So the lateral area of a cylinder is, again, it's just the sides, like it's just the like circle around the sides. Now before, when we talked about prisms, if we look down here, so if we talked about prisms, the lateral area was just the perimeter times the height. Now it's going to be the same thing with cylinders. It's going to be the perimeter times the height. But now we know a special way, like now we know a special formula to find the perimeter. Since it's a circle, the perimeter is just 2 pi r, right? That's the perimeter of a circle. And then times the height. So really the formula we're going to be looking for is 2 pi r h. Okay. So that'll give us the lateral area. And then the volume of a cylinder is going to be very similar to the volume of a prism, right? So volume of the prism is base times height. It's going to be the exact same thing here. It's going to be base times height. But we know the area of a base. What's the area of a circle again? That's right, it's pi r squared. So pi r squared h is the volume of a cylinder. Then we also, so I don't know why they don't put it here, but let's talk about the total area. So let's talk about the total area of the cylinder. So the total area of the cylinder is just going to be the area, the lateral area, plus both of the bases, so 2 times the bases. So the total area of a cylinder is going to be equal to 2 pi RH plus 2, and then the area of the base is pi r squared. And some people actually even go a bit further and they like make it more simplified. Since both of these have a 2 pi r in them, what they do is they factor out 2 pi r out of both of these, and then it'll be, if you factor out 2 pi r in this, it'll just be h left over, and if you factor out 2 pi r in that, it'll just be a r. Some people write it like this, which is fine, but as long as you understand that the total area is the lateral area plus the 2 bases, you're good to go. Okay, so that's cylinders. Now let's move on to cones. So cones are like a pyramid, but with a circular base. Okay, the term slant height only applies to right cones. So when we're talking about a right cone, so basically when we're talking about cones here, we're only going to be talking about right cones. So lateral area of a cone. So here we have the slant height and the height here. And we said this is very similar to pyramids, right? So if I go down here and I look at what we have for pyramids, oh, here we go. So the lateral area of a pyramid was 1/2 the perimeter times the slant height. Now it's going to be that same thing here for a cone. So lateral area is 1/2 perimeter times the slant height. This is how I write my L's, so get used to it. But we know a special formula for the perimeter, right? We kind of talked about it up here. The perimeter of this base here is going to be the circumference of the base. They're the same thing because it's a circle. The base is a circle, so it's going to be 1/2 the perimeter, just 2 pi r times the slant height. And then actually we can simplify this because 1/2 times 2 is going to be 1. So it's just pi r slant height. Cool. So that's the lateral area. Let's talk about the volume. So if we look at the volume of a pyramid, if we go down here, volume of the pyramid was 1/3 base times height. It's going to be that same thing. So it's going to be 1/3 the area of a base times the height. But in this case, we know our area of a base is going to be the area of that bottom circle, that base circle. So it's going to be 1/3 pi r squared height times height. And that's it. And then we can talk about total area. So total area is going to be equal to the lateral area plus one of the bases, because here we just have one base. So the lateral area is going to be pi RL, and the area of the base is going to be pi r squared. And again, some people like to rewrite this as factoring out a pi r, so it would just be pi r times L plus r. Cool. All right. So let's do a couple of examples. That's the bulk of the lesson, is just knowing these formulas and knowing what the different properties are. So here, for example 1 and 2, find the lateral area, total area, and volume of the following. So a cylinder with a radius of h and a height of 10. So let's start off. Let's do the lateral area. So lateral area, we're going to do, this is cylinder. I'm going to do this in red just so that we're all on the same page. Okay. So lateral area is equal to, if we look back up here, 2 pi RH. So it's going to be 2 pi, our R is 8, and our height is 10. Multiply all that out. 8 times 10 is 80, times 2 is 160, so we get 160 pi. Great. The total area is going to be equal to the lateral area plus 2 times the base. So lateral area, we just found out 160 pi. We got to add 2 times the base. In this case, well, the base we know here is pi r squared. So it's just going to be 2 times pi r, which is 8 squared. Squared. Okay. So 8 squared, 64. 64 times 2 is 124. So if I add these two together, I believe we are going to get 284 pi. Cool. And now we have the volume. So for the volume, look back up here. The volume is pi r squared h. So it's just going to be pi times 8 squared times 10. And when you do that, I believe you get 640 pi. So there you go, lateral area, total area, volume. All that was just plugging this radius and this height into those formulas. Cool. All right. Next, let's do, is this a cylinder again? It is a cylinder again. Okay. Well, let's do it again. So you basically just take 8 and 10, or sorry, 5 and 4, plug them into the formula. So, So that's 20, 40. So we got 40 pi. Total area. Again, this is all just plugging it in. So total area, we take the lateral area, 40 pi plus 2 times the base. Base is pi r squared, so pi 5 squared. And so it's going to be 40 pi plus 50 pi. It's going to be 90 pi. Okay, like I'm serious, everyone. It's literally just this easy. You just take the formulas, you plug it, you take these numbers, plug it in the formula. So pi r squared h, so pi r squared, so 5 squared times the height, 4. So 25 times 4 is 100, so it is 100 pi. It's just that easy. Okay. All right, next we have a cone. So next we have a cone here with a radius of 12 and a height of 5. This time we're given units, so we should probably pay attention to that. Oh, last one we were given units too. Oh man, I should go back and correct that. So here for the lateral area, it is going to be centimeters squared because we're looking for our area and we multiply it a centimeter times a centimeter, so it's going to be centimeters squared. Same thing with the total area, it's going to be centimeters squared, but for the volume, it is going to be centimeters cubed because we multiplied, we squared centimeters here, and then this is 4 centimeters, so squared times just 1, the power of 1 is going to make it the power of 3. All right, anyways. Next, we have this cone. So a cone with a radius of 12 meters and a height of 5 meters. So now we have to look at the cone formulas. So lateral area of a cone is pi RL. So lateral area of this cone is going to be pi r, which is 12, and L. Oh, hold up. We don't have the slant height of this. We have the height. So in order to find the slant height, what we need to do, if I were to look at this picture here, we are given the slant height, or sorry, we are given the height and the radius, but we are not given the slant height. So what could we do if we're given the height and the radius to find the slant height? Well, if you look here, it forms a right triangle. The height and the radius form a right triangle with the slant height. So you can just do the Pythagorean theorem. So 12 squared plus 5 squared is going to be equal to L squared. So that's 144 plus 25. So I need to bust out 144. Oops, that's 224. 144 plus 25, 169. Cool. So 169 is equal to L squared. That means L is equal to 13. Cool. So then we just take that, plug that in. And we get 156 pi. Cool. So that's the lateral area. Let's do total area. So total area is just equal to lateral area, so 156 pi. Plus the area of the base, which is pi r squared. R is 12, so it's just going to be 144 pi. Add those together. 156 plus 144 equals 300 on the dot, so 300 pi. And then volume. So for the volume, we're going to have to use the volume formula right here. 1/3 pi r squared h. So it's just 1/3 pi r squared, so 12 squared times h, which is 5. Bada bing, bada boom. Multiply it out. So I'm going to do 12 squared is 144 times 5. Divide that by 3. And I get 240 pi. So this is going to be meters cubed. This is going to be meters squared. This is going to be meters squared. So there you go. So this was all just like plug and play. You're given different parts. All you got to do is just plug them into the formulas. And now we are going to be given even more plug and play stuff. This lesson is just a lot of formula work. So if you know your formulas, you're looking pretty good. So complete the table for the cone shown. So we're given this cone. We're given 2 pieces of information. We got to find the third. Okay, so before we get started, I'm going to actually just write down the formulas up top just so that I have them. So lateral area is pi RL. Total area is pi RL plus pi R squared. And volume is 1/3 pi R squared times slant height. Wait a second. Yeah, not slant height. Height. Oof. Almost had a mini heart attack there. Thought I had the wrong formula. Okay, cool. So there we go. We're going to take these 3. Using these formulas, we are going to fill in the blanks here. Also in this picture, note that we have a right triangle here. So the height squared plus the radius squared is going to give us the slant height squared. Okay, so for this first one, we're given the radius and the height. So we're given this is 3, this is 4. So we need to find the slant height. So we're going to use the Pythagorean theorem for part A. So here we go. So we're going to have 3 squared plus 4 squared. Oh, whoops, I should switch those around. Doesn't really matter, but I'm going to, for the sake of you guys. So h squared is 4, so 4 squared plus r squared, r is 3, is going to be equal to L squared. So this is going to be 16 plus 9. 16 plus 9 is 25 equals L squared. And what times what gives me 25? That would be 5. So 5 is equal to L. You can also know that it's a 3, 4, 5 triangle, but I didn't know that. So I did the Pythagorean theorem. Cool. So lateral area, we just got to take our R, plug it in for R, our L, plug it in for L. So 3 times 5 is 15. So it's just going to be 15 pi. Cool. Now we're just going to fill this one out. So next we got total area. So we found the lateral area was 15 pi. So take just 15 pi here. Plus pi r squared. R is 3, so 3 squared, 9, so 9 pi. 15 plus 9 is going to give me, what, 24. So 24 pi. All right. And lastly, we got volume. So volume, we're going to take r squared, plug that in there. So 1/3 pi r, so 3 squared times the height, which is 4. Multiply that out. 3 squared is 9. 9 divided by 3 is 3. 3 times 4 is 12. So it's looking like it is going to be 12 pi. There you go. All right. So that's the process. Now we're just going to do this with different pieces of information given to us. So I'm going to erase this stuff, and we are going to do it with different pieces of information. A lot of just plugging in and playing. So this time we are given the radius and the slant height. We are not given the height. So how are we going to figure it out? Well, we have this formula right here, this Pythagorean theorem formula. So we're going to take R, plug it in for R, L, plug it in for L, find height. So I'm going to do that right here. So height squared plus 8 squared is equal to 17 squared. So h squared is equal to 17 squared. I don't know what that is, so I'm going to plug it in my calculator real quick. 289 minus 8 squared, which is 64, and that is 225. So that means that h is equal to whatever the square root of 225 is, 15. So h is equal to 15. All right. Now we just plug and play. So so to find the lateral area, we just got to take R and L here, plug them in. So it'll be 8. I guess I'll do it here. So pi times 8 times 17. So 8 times 17, 136. So 136 pi. All right, total area. So total area, we just take our lateral area, add it to pi r squared. So this is 64. So 136 plus 64 is 200. Nice. Next, we're going to use volume. So volume, I take my radius, which is 8, and my height, which is 15, plug them into this formula. So 1/3 pi r squared, so 8 squared times the height, which is 15. Multiply that out. So we're going to have 64 times 15 divided by 3, 320. Okay. Now, so that takes care of the first two. These first two were pretty straightforward. We just had to use Pythagorean theorem to find the missing piece and then plug all that in. So now this time what we are going to do is we are going to be given the volume and the radius. So from that, we have to discover everything else. So I'm going to erase my work here, and then we're going to give it a shot with the volume. Okay. So for this last one, like I said, we have, go do green. So for this last one, we're given the radius and the volume. So we need to use the formula for the volume to figure out a missing piece. So what I'm going to do is I'm going to rewrite the volume formula and just plug in everything I know already. So I know the volume already is 600 pi. 1/3 never changes. Pi is still there. R, do I know R? Yeah, R is 15. So I'm going to write right here, 15 squared. And then do I know my height? No, I don't. So that's probably what we're going to be finding on this first try. Okay, so now we just have to algebra this out and find the height. Okay, so I'm going to do that here. So I'm going to multiply both sides by 3 so that this and this cancel out. So 3 times 600, 1,800. Okay. And then, so 1,800. I'm just going to write this now, 1,800. Okay. So then 15 squared is 225. So then we just do 1,800 divided by 225. That's going to be 8. Also divide both sides by pi, the pi's cancel out. So we get a height of 8. Cool. So now that we have the radius and the height, now we just need to find the slant height. How do you guys think we should do that? Yeah, we should use this Pythagorean theorem formula. So we're going to take the height is 8 squared, the radius is 15 squared, and that's going to be equal to the slant height squared. So figure this out. 8 squared is 64. 15 squared is 225, which we just found out, and then L squared. So we do 64 plus 225, and that gives us 289. And give me L squared. Square root that, and you get 17. Hey, look at that. B and C are very similar. Okay. Anyways, so now we got all that information. Now we just take the radius and the slant height and plug them into that formula for the lateral area. So the lateral area is going to be equal to pi r, which is 15, times the slant height, which is 17. Multiply that out. 15 times 17 is 225. Is it really 225? 255. There we go. So 255 pi. And then the total area is going to be 255 pi plus pi r squared. So pi 15 squared. So 255 plus 225 is going to be 480 pi. Great. Okay. All right. Lastly here. So literally this whole lesson is just plugging in the things you know into, the formulas you're given. That's all it is. So make sure you have the formulas written down so that you can go through and just plug them in. Okay, example 4. So a right cone and a right cylinder have equal base areas. The height of the cylinder is 4 times the height of the cone. The volume of the cylinder is blank. Okay, so a right cone and a right cylinder have equal base areas. Okay, so the bases are the same for both the cone and the cylinder. All right, so what that means is, okay, well, whatever. So the height of the cylinder is 4 times the height of the cone. Okay. So what this means here, a right cone and right cylinder have equal base areas. So that means that pi r squared is equal to pi r squared. So their radiuses are going to be the same. Okay, so the radiuses are the same. The height of the cylinder, so cylinder height, we'll do it like this, height of the cylinder. Oh, that doesn't help. To height of the cylinder is equal to 4 times the height of the cone. And it's asking the volume of the cylinder is blank times that of the cone. Okay. Well, the volume of the cylinder is going to be 1/3 cylinder. So the volume of the cylinder is pi, well, let's check. The volume of the cylinder, so go all the way up. Volume of the cylinder is pi r squared h. So pi r squared hy. The volume of the cone is equal to 1/3 the area of the, well, let's check. 1/3 pi r squared h. So pi r squared hc. So it's saying the volume of the cylinder, so the volume of the cylinder is blank times that of the cone. So we need to make sure, we need to convert this height to the height that the cylinder would have while using this conversion here. So basically I'm going to take this and plug it in for that, the height of the cylinder. So if we're to do that, we would end up with something like this. Now we're going to write this phrase out in a mathematical phrase. So the volume of the cylinder, is equals blank times. So we don't know how many times, so I'm just going to put like x times that of the cone, volume of the cone. All right. Now we're going to take what we've got for the volume here and plug them into their respective spots. So I'm going to take all this stuff, plug it in for the volume of the cylinder. So pi r squared times 4hc is going to be equal to x times this stuff. So if I'm going to write all this out, so I'm going to write all this out as just things being multiplied together. So times 4h, okay, is equal to x 1/3 times pi r squared times h c. So looking at all this, we have a bunch of common terms. On both sides, we have like the same variables here. So since all this stuff's being multiplied, if I were to divide this entire thing by some of these things, or if I was to divide both sides by the same thing, what could I divide by that would cancel out the most things? Well, both sides have pi, so dividing by pi would be good. Both sides have r squared, so dividing by r squared would be good. And both sides have this height of the cone. So I'm going to divide both sides by that height of the cone. And if we do that, a lot of things cancel out here. So I'll end up with 4 on the left side. And on the right side, I'm going to end up with 1/3 x. So then to cancel it out, I'm going to multiply both sides by 3. And I will end up with 12 is equal to x. So that answers our question here. So the volume of the cylinder is going to be equal to 12 times the volume of the cone using this formula. So that was a lot, but basically what we did is, since we knew everything was pretty much the same between the two, except for the volume of the cylinder is 4 times that of the height of the cone. In the formula for the volume of the cylinder, we just replaced the height with that of the height of the cone. So 4 times the height of the cone. Then we just wrote this last sentence out in mathematical, like in a mathematical sentence here. So the volume of the cylinder is blank times the volume of the cone, and then just solved it for that blank, solved it for that x. We got 12. So we plug that in. So yeah, those are your guys' notes. A big takeaway is that the lateral area, total area, and volume of cylinders and cones are very similar to prisms and pyramids, except for now we're dealing with circles as bases. That's the only difference. And it's just a lot, and when doing these examples, it's just a lot of plugging into the formulas. I think we actually did too many examples because it's all pretty much the same thing. You just plug it into the formula. All right. Thank you guys for listening, and hopefully you guys find these notes useful. If you have any questions, please comment in the section below, and I will see you all in class.